All right. Yeah. So, welcome guys to this beautiful live video. Yeah. Let's do something under kinematics. I was disappointed in the performance for today's exercise. It showed that we are lacking a lot of information. Indeed, we are. So let's put something in your brain. Okay. So I hope everyone is doing fine. When you join, kindly comment your name. Comment your name so that we get to know each other. Simply comment your name. I can see you are joining. Comment your name so that we know each other. If you can't comment your name, just raise a hand to show that you're present. In the comment section, show your hand. All right. So we are going to be looking at under questions concerning kinematics. Kinematics, this is the study of motion. The study of motion is a field of mechanical physics which has to do with motions. Anything that is in motion is under kinematics. Anything that is moving is under kinematics. So under kinematics, we have a lot of things. We have the horizontal motion, we have the vertical motion, and the combination of the two, which is the projectile motion, where we have to combine the motion in the vertical and the one in the horizontal. Okay, so today we are going to look at horizontal motion alone. So horizontal motion. So for this one, I prepared a few questions. These questions are actually so good, beautiful, and quite examinable. You know what I mean when I say that. So make sure that you have at least a plain paper or a book where you are supposed to take note of something that will help you to understand much better. So yeah, this is the question here. This is the question coming from the tutorial sheet 3, 2023-2024 academic year. So this is for this academic year. And the question reads, this is question 12, tutorial sheet 3, 2023-2024 academic year, question 12. So you can check that question out. I just had to copy it because I can't share a document or a picture on a Facebook live video. Yeah. So the question reads, just as a car starts to accelerate from rest at a constant acceleration of 2.44 meters per second squared, a bus moving at a constant speed of 19.6 meters per second passes the car in a parallel line. How long does it take the car to overtake the bus? This is time. Definitely when you hear the question how long or when, just know that they are talking about time. Then the other question says, how fast is the car moving? Meaning we need to know the final velocity of this car because it started from rest, meaning it was accelerating. So the final velocity at which it had to overtake the bus. Then the last question says, how far has the car gone at that point? The question how far or where simply means the displacement. From the point where it started, how far has it moved? So that is the displacement. I'm pretty sure you are able to follow that one out. So let me read the question again. Just as a car starts to accelerate from rest, meaning it's starting from rest, it wasn't moving, at a constant acceleration of 2.44 meters per second squared. This means the velocity was changing at 2.44 meters per second squared. A bus moving at a constant speed of 19.6 meters per second. So a bus was just moving at constant speed. It was not accelerating or decelerating. Passes the car in a parallel line. Now what does it mean in a parallel line? Okay, so I'm trying to illustrate something here. Parallel lines, these are lines that can never meet. So we have a car there, I'm not good at drawing, but then you're going to get something from this. Okay. And then we have the bus. Okay. Something like this. Good. So these are going in the same direction. These are going in the same direction. So the car was at rest. It was not moving. The bus was already moving. They are in the same lane, in different lanes, but they are going in the same direction. Yeah. So the car was having the initial velocity of 0 meters per second, while the bus was already moving at 19.6 meters per second. I think we can copy that one. So the car to accelerate and start now moving to catch the bus, because the bus passed with this velocity 19.6 meters per second. So we need to analyze this question very well, and let me use a good paper to actually analyze the question. So do solutions of that question that I presented there. So let's follow the solutions now of the question I just presented. So just as a car starts to accelerate from rest, that question just as tells us to say the motion of the two vehicles were started at the same time. That's what it means. The motion of the two vehicles started at the same time. That's what it means. Because they are saying that just as the car starts to accelerate, the bus passed it with a velocity of 19.6 meters per second. The network is not too good. The network is not too good. Okay. Let's check the network. It's not too good. It's not too clear. Okay, it's back. Okay. The network is better at least. Yeah. So just as a car starts to accelerate from rest at a constant acceleration of 2.44 meters per second squared, that tells us that just as means the same time. At the same time, when the car started to accelerate, the bus had to pass it. So when we analyze the two, we are going to have car, anything that falls under car, and anything that falls under the bus. So we are saying that the acceleration for the car was 2.44 meters per second squared. Good. Then what was the acceleration for the bus? 0 meters per second squared, because it was at constant velocity. Then what was the initial velocity of the car? We have 0 meters per second. It was not moving. It started moving after the bus passed it. In fact, immediately the bus reached at its point, that's when it also started accelerating in pursuit of the car. Okay? So, what was the final velocity of the car? We do not know. Because this final velocity is the velocity at which it is going to meet the bus. So, what was the initial velocity of the car? We have 19.6 meters per second. And the final velocity of the bus is the same thing as 19.6 meters per second, because the velocity of the bus was constant. Then the two shared the same time, because the question says just as the car starts to accelerate, the bus passes it, just as. So the time that they took for them to actually meet, or for the car to overtake the bus, is not known. We are just going to call it time, t. And the time for the bus at which the two met, they took the same time, which is t. Are we together? Because the time was the same. What about the displacement that the two vehicles actually had to cover? The displacement is always also the same, because as they started, it is that they're going to meet at the same what? At the same distance, they cover the same distance for them to meet again. So we are going to have displacement there, unknown, and also there displacement 1 and displacement 2, so also unknown. All together. So let me try to also put that one. This is the car. This is the car. This is the car. And then we have the bus somewhere here. The bus somewhere there. So we have the bus somewhere there. So we have the car with the initial velocity of 0. We have the bus with the initial velocity of 19.6 meters per second. So 0 meters per second. Okay. These two cover the same displacement for them to meet. So this is S2 for the bus from where they started from. This one also had S1, meaning at which at the point where the car had to overtake the bus, they had to cover the same displacement. The time that they started with it was time was 0. So we started measuring the time when it was 0. Then final time was t. The final time was t. The two were moving in parallel line, meaning they were just moving, next to each other. But then the car was accelerating whilst the bus was at constant velocity. So acceleration is 2.44 meters per second squared. Good. So with this information, we are going to look at the thing that the two vehicles are sharing. So we can look at it and find that the time for the car, so let me use this, I'll use TC, time for the car, and T of bus, TB, time for the bus. Time for the car and time for the bus are the same, which is equal to T, just T. Then displacement for the car and displacement for the bus, these two are also the same. They cover the same displacement within the same time. I think you can see that one. So from that one, we are now supposed to do what? To form up or to come up with an equation that is going to satisfy all this information that we have in here. So we have the time, the displacement, and the acceleration. We have also here the time, the displacement, and the acceleration, and the initial velocity. That is what we are interested in, and the initial velocity. The only equation that can combine all these three is the base equation. The only equation that can combine these three is the base equation. Now, how is the base equation? So the base equation, let me to put this aside. The base equation is the very much common equation that we use in motion, which is S is equals to ut plus 1 over 2 at squared. That is the base equation. This is the base equation, which is used almost in all kinematic questions. It's very much popular, it's very much common. So that is the base equation. So looking at it, we have something that we already know. For the car, we are going to have S is equals to V initial times time plus 1 over 2 acceleration times squared. And for the bus, we are going to have S is equals to, so this is S1, this is S2, is equals to V initial time plus 1 over 2 acceleration times squared. Yes. So getting the information that we have here, we have the acceleration for the car as 2.44, and we have the initial velocity for the car as 0, and we have the time for the car as t, we don't know it, and the displacement as s1 as it is. So we are going to plug in this information in this equation, because we know the final velocity, meaning it's not needed in this equation. Are we together? So we are like s1 is equals to velocity initial for this one is 0 times time plus 1 over 2 acceleration is 2.44 times z time squared. Time was still t, so it just be like that. We have 0 plus, when we divide 2 with that one, 2.44 over 2, we are going to have 1.22, then times z time squared. So we're going to have S1 is equals to 1.22 times squared, equation 1. This is so simple. So in terms of displacement, in terms of time, I mean, we can find the displacement of the car, which is S1. So displacement of the car is given by 1.22 times time squared, which time we do not know. So we go also for the second motion, which is for the bus. So for the bus, we have S2. What do we have? Acceleration is 0, initial velocity is 19.6, and time is t. So displacement is equals to initial velocity 19.6 times time plus 1 over 2, 0 times time squared. Now when we say 0 times time squared, everything here dies, is 0. So we have S2 is equals to 19.6 times time, we have the times there, plus 0. Then we have S2 is equals to 19.6 time. This is the equation 2. Now, we should remember that the two vehicles actually at the same displacement for them to meet again or to overtake, for the car to overtake this one. We have the same displacement. So we are going to say that S1 displacement of the car is equals to the displacement of the bus. The moment you come up with this one, that means this other side is equal to the other side. So for time, because that's what they asked for. They said, how long will it take the car to overtake the bus? So now you can equate this one to that one. We have 1.22 t squared is equals to 19.6 t. Then we can take this one the other side, 1.22 t squared minus 19.6 t is equals to 0. Then we can factor out the 1.22. So 1.22 t is equals to t minus, so I'm going to use the calculator and divide, because I know that once I divide this into that, I remove this into that one, the same thing as I just divide. So I'll divide this 1.22 into 19.6. So 19.6 divided by 1.22, I'm going to get 16.0655. Okay, it's just like that one, is equals to 0. Then I have to equate this. It's the same thing as 1.22t. 1.22t is equals to 0, because this is a quadratic. Definitely are going to have two values. Then you're also going to have t minus 16.06557 is equals to 0. So if we actually divide by 1.22 for this one, we have t is equals to 0. So this t is equals to 0, it means the first meet that these two had is when they just started. T is equals to 0. We are expected to have 2 points at which they met. So they met at this instant when time was 0, and another instant when time was something else. So time is equals to, we take this to the other side, we have 16.06557 seconds. This is 0 seconds, and this is 16.30. Rounding of this one, we can just get 16.1 second. So this is the time that we want, because the two had to meet at two instances. The first one when the time was 0, when they were just recording the motion, and the second one when time was 16, after 16.1 seconds, they had to meet again. So this is the time that we are requiring. This is the time that we need for us to actually say this is the point at which the car had to overtake the bus. I'm pretty sure that is so well explained. If you have any questions, please. The questions. So I'll read the question again. Someone is asking for the question. I'll read the question again. So the question is here. Tutorial sheet 3, 2023-2024 academic year. That is tutorial sheet under kinematics sign. Just as the car starts to accelerate from rest at a constant acceleration of 2.44 meters per second squared. A bus moving at a constant speed of 19.6 meters per second passes the car in a parallel line. How long does it take the car to overtake the bus? We have answered this one. Time was 16.1 seconds. Then how fast is the car moving? The velocity of the car. We just know the initial velocity as 0. What about the final when they met? We need to find that one. And the last question is, how far has the car gone at that point? How far simply means the displacement. So we are going to find the second question, which is saying, how fast is the car moving? How fast is the car moving? Meaning, at this instant, when time was 16.1 second, how fast was the car moving? It had the initial velocity of 0, but how was its final velocity when time was 16? So let's do that question also. Let's solve that good question. So this one, the question how fast is the car moving is going to be broken down by velocity final is equals to velocity initial plus acceleration times time. Because know that the time now is 16.1 seconds, the acceleration is 2.44 for the car, meters per second squared, and the initial velocity for the car is 0 because it started from rest, 0 meters per second. So we plug in these values, we find the final velocity of the car. So we have final velocity is equals to the initial velocity was 0 plus acceleration 2.44, then multiplied by the time 16.1 second. Then velocity final is equals to 0 plus what are you going to get when we say 2.44 by 16.1? We have 39.284 meters per second. So velocity final is simply going to be 39.284 meters per second, which can be rounded off to 39.28 2 decimal places. So the car now was at 39.28 meters per second as its final velocity the moment it overtook the bus. Then the other question asks to say, how far has the car gone at that point? So now the question, how far has the car gone, is the same question as how far has the bus gone at that point. Reason being, the reason is we know that the two displacements are the same. So if we say how far has the car gone, we're actually finding also how far has the bus gone, because the two displacements are the same. As the car overtook the bus, there it had covered the same displacement as the bus. S1 is equals to S2. Okay? So we are going to actually move with that one by finding how far has the car gone. Now remember that we have this. For the car we have the displacement, which is S1 is equals to 1.22 times time squared. Now the time we have already found it. Let's just plug the time in there and then we can get our displacement of the car. Are we together? We have found the time to be 16.1. We replace it there and we have the displacement of the car at that instant. Okay? So we proceed. We can call that 1.22 time squared, or the equation for the displacement of the car. Displacement of the car, where time is given as 16.1 seconds. These are applicable questions, very nice and very examinable. So let's plug in the 16.1 in that. We have 1.22 times 16.1 squared. Very much careful. We have 1.22, then 16 squared will give us what? 16.1 squared is giving us 259.21. 259.21. Then if we multiply that by 1.22, we are going to obtain 316.2362. S1 is equal to 316.2362. 0.2362 meters. Remember, this is displacement. It's supposed to be in meters as the SI unit of displacement. So S1 is going to be given by 316.24 meters. Round off to two significant figures. So at distance or displacement of 316.24 meters, the car had to what? To overtake the bus. Okay, so this displacement is simply 316.24 meters, meaning this one also is 316.24 meters, because the two, they actually met at the same time. I mean, the car overtook the bus when they are the same time and the same displacement. So you can also prove this by using S2. So you can use S2, the equation for S2, to find the 316. You can plug the 16.1 second in the equation for S2 and the answer will still be the same if you use S2 there. Just do 19.6 times 16.1. So you have 19.6 times 16.1. And the answer is still the same. Just because of the rounding off of the figures, we have 315.56 because we rounded off some figures from the time. Otherwise, the answer is still the same. So the two had to actually meet, or the car had to overtake the bus at 316.24 meters within 16.1 seconds. Okay, and the final velocity of the car was 39.28 meters per second. I'm sure this one is very well explained. So if you are following, please, if you have any questions under this one, let's ask so that I can answer your questions as soon as possible before I move to another question which needs more of the understanding. Please, if you have any questions under this one, raise them down in the comment section and I'll be able to assist you before I move to the next question that involves critical thinking. Okay, if you have any questions, I'm kindly asking if you can drop them down. Maybe your friends might have the same question. Then if there are no questions, please type up that you are okay, you are following. So these are the values that are expected to be gotten from question 12 in the tutorial sheet for kinematics. Okay, then I've seen that nobody's asking and a lot of you are actually watching. That means you are following. Let me move to another question that needs some of the thinking that actually is a bit critical. Okay, so the second question that was prepared is coming from the same tutorial sheet. We're talking about the tutorial sheet because tutorial sheet questions are likely to be examined. Okay, so this question is coming from the tutorial sheet 3. Tutorial sheet 3, 2023-2024 academic year, that is CBU exactly. So this tutorial sheet 3, 2023-2024 academic year, question 4. So question 4 in that tutorial sheet, you are going to find this question exactly the way it is, the way I've written it here. So let's take time to analyze the situation. So the question goes, a motorcycle policewoman hidden at an intersection observes a car that ignores a stop sign, crosses the intersection and continues moving on at constant speed of 72 kilometers per hour. The constant speed of the car was 72 kilometers per hour. Keep in mind that this velocity is given in kilometers per hour, which is not the SI unit of velocity. Meaning, as a physician, you need to actually know what you need to do with these units before you do anything. I'm pretty sure you can understand what I mean. So, the question continues. 2 seconds after the car crosses the intersection, the policewoman starts off in pursuit, accelerating uniformly at 3 meters per second squared. 3 meters per second squared until she catches the car. So this is a very good question, talking about practically what happens. A motorcycle policewoman hidden at an intersection observes a car that ignores a stop sign, crosses the intersection and continues moving on at a constant speed of 72 km per hour. So the car had to actually cross the stop sign without stopping and was moving at the same constant speed, which is 72 kilometers per hour, without stopping. So the police woman actually saw that, and she had to actually start chasing the car. Now what happened is this: the car had already passed. That's when the police woman started what? Following. We can see that they said 2 seconds after the car crosses the intersection, the police woman starts off. 2 seconds after the car crosses the intersection. That is very, very important to note. The other question, we had that the 2 times were the same. Are we together? So the 2 times were the same, and that means us having the 2 times which were the same, we just had 2t, the final time, as the final time for both the cars. But here we have the 2 times that are different. The car had the time, which is time is equals to the final time was equal to time, but this policewoman had to wait 2 seconds for her to start off chasing the car. So meaning the time of the policewoman is different from the time it takes for the car to actually meet for the policewoman to actually catch the car. The 2 times are different. We can see that the car started off, passes, then the policewoman started following after 2 seconds. So the 2 times are not going to be time is equals to time. No, the 2 times are going to be different because the policewoman was 2 seconds late. Okay, the policewoman was 2 seconds late. After the car started off, that's when the policewoman now started also off after 2 seconds. Good. So the question continues. 2 seconds after the car crosses the intersection, the policewoman starts off in pursuit, accelerating uniformly at 3 meters per second until she catches the car. Okay? The question reads, how long does it take the motorcycle to catch up with the car? So this is still time. How long, when, this means the time. Then the second question reads, how far will the car move when this happens? So how far will the displacement, what will be the displacement of the car when the 2 meets, or when the police woman definitely catches the car? How much displacement has the car covered as it was caught at that point when it was caught from the intersection where they started chasing each other? I think we can follow up with that question. Let me read the question again. A motorcycle policewoman hidden at an intersection observes a car that ignores a stop sign, crosses the intersection and continues moving at a constant speed of 72 kilometers per hour. So let me try to at least illustrate something here. This is the stop sign. Stop. There. The car actually continues to pass because it reaches at that point. Then the time that this car started off with 0, definitely 0 to the final time as t. Now if the final time is t, the policewoman had to wait for how many? For 2 seconds for her to start off. So 2 seconds after, the policewoman started chasing the car. So what will be the time, the final time for the policewoman? T minus 2 seconds. You need to take very much note of this. T minus 2 seconds. So if the final time for the car was, let's say, 8 seconds, the time that it takes for the policewoman to catch the car will be 6 seconds. We have 8 minus 2, which was already lost. The policewoman had not started chasing the car after 2 seconds. That's when she started chasing the car. So the 2 times are not going to be the same. Please pay attention to this one. It's a very, very important point that you need to take care of. So you are saying that the 2 times are not the same. The time for the policewoman and the time for the car are 2 different times. Reason being, the policewoman started chasing the car after 2 seconds, meaning if the time total is actually 8 seconds, that means the time for the policewoman will be 8 minus 2 seconds, which was already wasted. The policewoman had not started chasing the car in that time. Are we together? Yes. So let's analyze the situation now. Let's analyze the situation. We need to collect the information from both the motorcycle, policewoman, and the car. So we'll write here. I'll write here. What I'll do is I'll write policewoman. Everything that falls under the policewoman will be written here, and everything that falls under the car that crossed the oasis will be written there. So anything under the policewoman, we are saying that the policewoman had an acceleration of what? 3 meters per second squared. Good. Initial velocity was 0 because she was standing there. She was waiting. She was hidden. Okay. So what other thing do we know? Final velocity of the motorcycle or the policewoman was not known because we don't know when they met at that point. We don't know the time. We don't know the displacement. So final velocity is not known. Are we together? Then the time for the what? For the policewoman, I'll put PW. Time of PW is gonna be total time minus 2 seconds. Total time that it took for them to meet minus 2 seconds because the policewoman was late by 2 seconds. So the one that is late by that time should carry the negative. Are we together? So the one that is late, that time should be subtracted from the total time that it takes. Very much important. The acceleration of the car was 0 because it wasn't accelerating. Then the initial speed was 72 kilometers per hour, which when you convert this one, let me convert it first. Okay. I have 20 meters per second. That's the first thing to do. As a physician, you need to make sure that you know what you are doing. You can't deal with kilometers and meters here. Here it's meters per second, then here you have kilometers per hour. That is a very big error. So convert the units into the SI units before you start working. So this 72 kilometers per hour is simply 20 meters per second. Okay? Then we have the velocity final of this one, which is the car. It's the same thing because it was constant. Okay? Then we have the time of the car. Time of the car, we will just take t because for it started with 0 time reaching at what? At t, the final time. But for the police, she was late by 2 seconds. That's why we are saying that total time minus 2 seconds will be for the police. I'm sure that is very much clear. Then displacement of the car is going to just be displacement, which we don't know, and displacement of the for the policewoman, and displacement of the car will also be, which we do not know. Now we need to understand something. Okay, the stop sign is here. Let me repeat that point. The car starts there, and then the policewoman also moves there. So here the time for the policewoman is t minus 2, but the time of the car is policewoman, okay, is simply t. Is simply t, because started from 0 to that. This one started from minus 2. Already they wasted 2 seconds before the policewoman could start chasing the car. But the displacement that they cover is the same from there to where the policewoman is going to meet or to catch the car. Definitely they have the same displacement. So this is S1 and that is S2. So the two displacements are the same. They started measuring the displacement from the stop sign there, from the intersection to where they reached. Though they are two different times for them to meet there, but they shared one thing in common, which is the displacement. All together, they both covered the same displacement, despite them having the different times to cover that displacement. Are we good? I'm sure you are following. So what equation is going to actually contain the time, displacement, and the initial velocity? Acceleration also. Time, displacement, and initial velocity and acceleration. The only equation that is suitable of combining these given quantities is definitely the base equation. You need to be very much good with doing the base equation. So the base equation is simply s is equals to ut plus 1 over 2 at squared. Now this equation, you know it from back home, from secondary. This is a very good equation. Okay, so we are going to actually have two things. Definitely, as usual, we are going to have two things. We are going to have the policewoman and the car. So you have to summarize these two things. So S1 for the policewoman is equals to velocity initial times time plus 1 over 2 acceleration times time squared. Then here also you have S2 is equals to velocity initial times time plus 1 over 2 t squared. Definitely the same things. But as we start plugging in the values, we have S1 is equals to velocity initial 0 times time plus 1 over 2, acceleration is 3. Then time of the police woman is t minus 2. So while there is time, we put t minus 2 squared. All together, very important. Please, you need to take care of that. The time of the policewoman is t minus 2. So where there is t, put t minus 2 and square it. So we're going to have S1 is equals to 0 plus 3 over 2 t minus 2 squared. Good. 3 over 2 t minus 2 squared. That one is very important. That one is very much important. That one is very much important to take care of. You need to make sure that you are good with summarizing such kind of cases. Then we have this equation as equation 1 in terms, let me finish it. 3 over 2 t minus 2 squared. You can just keep it like this. You have it as equation 1. For the policewoman, you go to equation 2. S2 is equals to, what is the S2? Now we have velocity initial. Velocity initial is 20 times time plus 1 over 2. What is 1 over 2 that we have there? 1 over 2. What is our acceleration? 0. The time for the car is still t. So you just square it. It's still t there. It's still t. This one was t minus 2. So S2 is equals to 20 t plus 0. Then S2 is, because of this 0, everything here dies. We have 20 t, equation 2. All together, I'm pretty sure we are following what is happening. So the concept that I wanted to bring out here is the difference in the time. The difference in the time. That one that we had in the first place had the same time. This one, 2 different times. The policewoman was late by 2 seconds, and we are saying the final time minus 2 seconds is for the policewoman. But this car was not late by any seconds. That's why the time is equal to the final time. Very much important. So we can equate the two equations because we said that S1 is equals to S2. Here, they cover the same displacement. Though it's different time, but they cover the same displacement within those two times. So what do we have to do? We have to equate this to that. And we have to know that S1 is equals to S2. This is one thing that is so common about these two. They are sharing the same displacement, meaning we are going to equate this to the other side. If S1 is equal to S2, we can equate this side to the other side. Good. So someone said it's giving simultaneous equation. Yes, simultaneous equation, because we have two things to solve for. S1, which is equal to S2, and what? And also time. So since S1 is equal to S2, it's the same thing as just equating this side to the other side. Because S1 is already equated to S2, so you can equate this side to the other side, you are good to move. Okay? So we have S1 is equals to 3 over 2, t minus 2 squared. Then S2 is equals to 20t. Then we equate the two. Let's solve. Let us solve nicely. Okay, so we are going to have 3 over 2 t minus 2 squared is equals to 20t. All together, then we can simply multiply everything by 2 to get rid of the denominator 2. So here we are just going to have 3t minus 2 squared is equals to this times that, which is 60t, because 2 times 40, sorry. 40. 2 times 20 is 40. Are we together? Then as we expand this, we know that what we are going to come up with is a quadratic equation. So let's expand what is there. So we have 3t minus 2 times t minus 2 is equals to 40t. Are we together? Are we following? Please, if you are following, let's respond. So 3, keep it well. T times t is t squared. T times that minus 2t. T times that minus 2t. 2 times 2 is positive 4. Okay, we have that one. Then we have to simplify inside. T squared minus 4t plus 4 is equals to 40t. Then we distribute the 3 at the end. We have 3t squared minus 12t then plus 12 is equals to 40t. Let's bring this t here. We can have a quadratic key. The moment we bring this t the other side, we can have a quadratic key to be equated to 0. 3t squared minus 12t plus 12 minus 40t is equals to 0. This and this can add. 3t squared minus, what is this going to be? 40 minus this one. We have we're going to have 12, which is 52. Good. 52t plus 12 is equals to 0. Yeah, that is very much important. That is very much important. Then this quadratic should be solved very well. Now, as we solve this quadratic, we have this one. This formula is very important. Minus b plus square root of b squared minus 4ac over 2a. Now, in this case, we are saying that this one, we just use the positive value of the square root, because time can never be negative. If you have this negative minus negative, we have a time which is negative. So ignore the negative part and follow the positive part alone. So we are getting rid of the negative because we know that we have two values, plus or minus. In this case, the minus one, ignore it. We are talking about time, which can never be negative. So please get your a from the equation, which is 3, get your b, which is minus 52, and get your c, which is 12. I'm sure you are following. So the b is minus 52, the c is 12, and the a is 3. Let's plug in that one. T is equals to minus 52, negative, very much important, plus square root of minus 52 squared minus 4. What is our a? 3. What is our c? 12. Over 2. A is 3. Good. T, it will be 52 positive because of minus there. Minus and minus will give positive. Plus square root of 52. 52 squared, sorry. 52 squared, that is 2,704. Then this one will be minus 4 times 3 times 12, which is 144. Okay? Yes, 144 over 6. 2 times 3 is 6. Then we are going to have t is equals to 52 plus 2,704 minus 144. So 2,704 minus the answer, we are getting 2,560. 2,560 over 6. So let me bring a new paper. I think you are following. Follow what is happening. Follow what is happening, so that you are not behind. So now I'm going to get a new paper and plug in what we have there. So we have simple thing that we have there is sorry about that. Sorry about the disturbance. We have t is equals to 52 plus square root of 256 0 over 6. T is equals to 52 plus square root of this answer is 50.5964426 over 6. So t is equals to, when we add the 2, we are going to get, so we have plus 52. We have 102.596444256. Everything over 6. Be accurate. Time will be equal to that one divided by 6. 17.099407009 seconds, which can be rounded off to 17.1 seconds. So this is the time that it took for actually the policewoman to catch the car. This is the time it took. You can see that for this one that had 2 different times, we have something that is different. Are we together? We have even reached to the quadratic. So you need to actually pay attention to that. And that's the reason why I had to prepare 2 different questions to make sure that on each kind of a case, you have some ideas. Are we together? Yes. So that is the time that it took. So we have answered the first question, which says, what was the question? How long does it take for the motorcycle to catch up with the car? Okay, how long does it take for the motorcycle to catch up with the car? So the second question, which is B, says how far will the car move when this happens? We go back to the equation that we got. We have this. The policewoman is this and the car is this. So how far will the car move? We have S2 is equals to 20 time. Our time in this case is 17.1 seconds. So we replace there. S2 is equals to 20 times 17.1 seconds. S2 is equals to 20 times answer. We have 341.988 meters, which you can round off to 342, because when you get the 80 there, we just have 342 meters. So this is how far was the car the moment it caught up with what? The policewoman. Are we together? And this displacement is the same as this. If you replace time while there is t, you are going to find that the 2 displacements are the same. You can replace time there. We can see 17.1 minus 2. Then we square this value. We multiply it by 3. And then we divide by 2. We have 342 exactly there. We have 342. So even if you use this equation, you just put the time 17 minus 2, then square it and multiply by this. You find that the 2 displacements are the same as putting the time on that one, because the 2 vehicles had covered the same displacement within within different times. The first question that we had, they have covered the same displacement within the same time, but in this case, the 2 have covered the same displacements within different times. The first time is for the time for the car, which is 17.1, but the time for the policewoman will be 17.1 minus 2, because the policewoman was late by 2 seconds. You need to be very much clear with that one, meaning this one was 15.1 seconds. So the policewoman took 15.1 seconds to actually catch the car, but the car had already moved the same distance, which is this, within 17.1 seconds, because it was already moving before the policewoman could start chasing the car. Are we together? I'm pretty sure this one has given you some ideas. In fact, the more concept that you need to understand under the horizontal motion kinematics. Definitely those questions that are applied and questions that are examinable. These are 2 good questions that each and everyone should be able to actually get something from, because these are the kind of questions that they ask and they give them 8 marks, 7 marks, and you wouldn't miss all those marks if you want to get that A+. You need to actually be good. So I'll read the question again and then you people can solve. I wanted to give you one question, but not here. I'll give you in the group on our WhatsApp. So those that are not in the group, you can still text through the same page. We have the button that takes you to our WhatsApp group, where you can actually join the group and at least get something. I'm very happy that we have a good number of you actually attending or watching, and I'm pretty sure that those that are sleeping will actually find this video tomorrow morning and watch it. I'm pretty sure you've enjoyed the lesson. Those that would want to say something or ask anything concerning the lesson or concerning our tuition program, please, you can still drop that one in the inbox, or just here you can ask. I'm still checking. Okay, if you have any questions concerning the lesson, you can definitely ask that question, please. If you have a question, type it up, please. Let me read your question before the video ends. Type up the question, type up. Answer for the last part of question 1. Okay, let me view that one for you. The answer for the last part of question 1, the answer was, so the answer for the last part of question 1 was 316.24. Okay, so the answer for the last part of question 1, we had the final velocity at 9.28, and we had 316.24 meters. So this one is asking how much is 2 courses. So 2 courses are going at 200 kwacha for the whole term. Please, 2 courses is 200 kwacha for the whole term. So a course is 100 kwacha, so it depends with how many courses want to enroll. We have 4 courses: BI 110 biology, PH 110 physics, MA 110 mathematics, and CH 110 chemistry. So you can still inbox us. Each course is simply 100 kwacha for the whole term. Very affordable. So this is the last part. The one that was asking for the last part, they asked for the displacement of the car. Yes. So that was 316.24 meters, please. Thank you so much. Make sure that you enjoy the video. If you have any questions, you still go through, get a paper, take something from the what says the lesson. Yes, those are the main concepts under horizontal motion. If we have more, I'll still bring more questions. Next time we're meeting, we are going to actually focus on the vertical motion. We need to understand also object falling and object thrown upwards, and what happens, and how that acceleration, the gravity, affects that motion. Okay, so she asks the question. He asks, Innocent says, I'm behind on putting acceleration. Are we not supposed to use the one for gravitation? Okay, Innocent, when you remember that when you started, we are saying horizontal motion. Okay, let me show you that with that paper. Here, Innocent, here. Horizontal motion. We are talking about a car. Okay, so a car cannot move going upwards. That is impossible. We can't have a car moving upward, going against gravity or falling. A car moves in an horizontal manner, so it has its own acceleration. Are we together, Innocent? The car has its own acceleration because it's horizontal motion. Then we are going to talk about vertical motion. As I said, this one is the one that involves the gravitational, because objects that are falling and going up are actually involving gravitational force, which is the gravitational acceleration. So this one was horizontal motion, focused on the given acceleration, given speed of the car. We just have vehicles moving in horizontal motion on the road. I'm pretty sure you are very clear about that, Innocent. So next time we are meeting, we are coming for the one that you know, which is the vertical motion, the one that involves object falling and object thrown upward. I'm pretty sure, Innocent, you can actually confirm that one. So I'll send one question in the group so that you can go through. This is very interesting. I love the fact that we've finished these 2 questions, which were a bit tricky to some students. Today you've gotten something Have a beautiful night, and make sure you don't forget to study. If you have not understood, please go through. So next time we are meeting, as I mentioned, we are going for the vet commotion that Innocent T was asking about.